Okay, so I got it recorded now. So for today's the agenda is pretty much we're gonna go over the first half of module 11, which goes into the classful subnetting. Then once we get through with the classful subnetting, I plan on going over Kelly's I got a document from his video of the 7 holy steps, and that document is real good with showing you the kind of a easy format to get down the classful subnetting. So once you get down the classful subnetting, then going into the variable length subnet, it makes it a little bit easier. But that's the only plan I have for today. And then Wednesday, we're going to variable length subnet and look at some examples here. So you say you're having issues with 11.7.5?
I have issues with every packet tracer. Hold on, let me make sure I'm unmuted.
Okay,
yeah,
no
I have issues with it, and it's just that I sometimes feel like I'm super thick-headed here. You've gotten my emails. You saw how detailed the last one was, and I am sitting here.
Go ahead.
It frustrates me because there's not somebody I could turn to and say, is it this or that? Whenever I hit a little one. So that last email was me going through, and you got my stream of consciousness as I went through the packet tracer.
Yeah. So did I know I responded back to you, I think Sunday or Saturday. Did it answer back?
I have not gone back. I apologize.
Oh, okay. No problem.
I will go back. It's very much on my radar to go back and look at my question, look at your answer, and try and wrap my head around it a little bit better. There was that one thing where we were talking about, if I recall correctly, that was the IP6 addressing, and the IP6 addressing was truncated so much that, like in many instances, we have the : Okay, I get that if you put : that means we're eliminating the zeros.
Yes.
That clicks, but there wasn't that many colons. Like it wasn't :
So the
FE80, it was just : FE80. So where'd the rest of the zeros go from the whole thing? It's that kind of question, those kinds of questions.
Yeah, so here is and just so everyone's on the same page, me and Mike were talking about packet tracer 10.4.3, and hopefully you can see it on my screen here. So with 10.4.3, it's one of those packet tracers where you can get one of, I think it's like 3 or 4 different topologies. So usually we've reported this issue to Cisco, but usually when you have the packet tracers like that, what ends up happening is it's grading for one thing, but it's showing you another thing. So usually on these, I think for this particular one, your IP addresses for the router, most likely it's not going to grade it correctly, even though you may have it correct. So when you go to do your check mark here, go to assessment items for the college router, in my instance here, you see here's listing this address for the gig 00. It's listing 2001 DB8A:1. So when I go back to here, you see the addresses that it's giving me is something totally different. So with that one, that's one of the ones that we have reported it to Cisco. And with the shortening, what happens is, so in shortening the addresses, when you have a consecutive number.
Can you zoom in? Can you zoom in a little closer? Because I could,
yeah.
Even with my glasses on, I can't even see the numbers, but I'm not even sure. There you go. Oh, that's great. Much better. Thanks.
Yeah. So it shortens the addresses. So here you have 2001 DB8 CAFE:2:, and your first address will be a 1 here. So what it does is when you get into I think we may have passed it, where you drop the leading zeros from the IPv6 addresses. So technically, if we written this out the long form, it would be a 0 in front of the D. So you can drop that off. And then you have the CAFE:2. And these semicolons here is the consecutive zeros. So it may be like 0000, semicolon 0000, So instead of writing all those zeros, that's where the double colon comes in. But everything else, the
Okay,
zeros is dropped off, deleting zeros.
so
Okay, so Mike,
Yes.
when you
Yeah.
look, the directions told us that there was a glitch with it
Yes.
and to use a different address, but that didn't work either.
Yes. So
I'm with you on that.
Yes. So
Sorry.
with this particular one, even the addresses we had there, depending on which topology you get, it's not going to grade it correctly. So most of you probably just got up to like a 89% or 80 something percent. So just go ahead and submit that one because we know that there's issues with this particular packet tracer. And also with some of these packet tracers, especially the ones where you can get multiple topologies is where we see the most issues. But the packet tracer was good in the fact that it gives you practice. And then I know, Mike, one of your questions was about the IPv6 unicast routing.
Yeah, no, oh no, you answered the unicast routing.
Okay.
That one, that's basically no shutdown, right? It's the same thing.
Well, it's you have to. So with the IPv6 unicast routing, what that does is going to activate the routing process for IPv6. So without that command in there, you can go ahead and enter your IPv6 addresses on your interfaces, but nothing is going to route until you put in that IPv6 unicast routing command.
And then but isn't that the same thing as no shutdown? Because when you hit no shutdown on an IPv4 in a switcher router, is it a switcher router? See, these are the little details I get confused on. That turns on the interface, right?
Yeah,
No
so
shutdown turns on the interface.
So it turns on the interface. So it brings your interface from a shutdown mode to an up mode, to where if you got a device connected to it, that device will work. But it doesn't do anything with the whole routing process. It's just gonna shut down a port. So on the switch, for instance, let's say if we had a switch and we had one PC plugged up to port 1. If I didn't want that PC to be on the network, I can go in and shut down that port. So in a real world scenario, that would happen is, let's say we got a switch and a virus pop up on that PC. I can go, instead of me having to go directly and walk to that PC and find out what port is in and unplug that port, I can just go in and do a shutdown, and it's going to shut that port off to where anything connected to it is not going to work until I go in and do a no shutdown to turn it on. But once it's turned on, it's still the IPv6 routing is still not going to route IPv6 unless we have that command in the routing.
So in one case, it's literally controlling a port, switching a port on and off. In the other case, it's switching the routing on and off, but the port is on.
Yes.
Okay.
So by default, yeah, IPv4 it's already routing. That's why you don't have to enter any commands for it. But with IPv6, you have to turn on the routing for it, and that's with the unicast routing command.
Got it. So so yeah, I'll go through all of that. The FE, it's an FE80. It's the
link local.
Yeah, the link local. So you've got your link local address,
mm-hmm.
and in theory, it's supposed to be the same. That was another question. And when I did it, I got it wrong. But when I changed it to FE8, I think it's FE8001 off the top of my head, and then I changed it to FE8002. And the FE8002 actually gave me credit when I changed it to that on the second series of the second one, the second, I think, switch or the second router. I forget what it was. And so, but if I recall your email correctly, because those link locals are local to that interface, it is an IP6 address that sits inside that interface, and it doesn't talk to anything. It's just in that interface.
Yeah. So
in theory, I could have put FE8001 in all of them, and it should have worked, and I should have got credit.
Yes, but if it The only reason it may not have gave you credit is it probably was looking for that 02.
Right.
But
I just wanted to make sure it wasn't wrong.
In a real world scenario, FE80 semicolon 1, I could put it here on this gig 00 interface, and I can also put it on the gig 01 interface. The reason is because that link local address is only specific to this link. It can't talk any other outside of any other interface. But in some scenarios, like to keep the organization, like you don't want all of them to be FE80 semicolon 1, because then if you had issues of some sort, you would have to go and check every interface. So you could say, okay, FE80 semicolon 1, FE80 semicolon 2. And if we had another connection here, then we could go with 3. But they're not able to communicate outside of its link.
I got, maybe I can, well, this is how I look at it as
Yes.
it's like a broadcast domain, right? So you had to have the Marco pointed in that. Now that local link is just for that local network.
Yes.
For that particular broadcast domain. So it's not going to go outside of that broadcast domain.
Yeah.
So that number, you're right, could be the same number. It doesn't matter unless you change your network on the IP version 6 for another domain, and you might have the FE02 or something like that.
Yeah.
For the link local for now, for that broadcast domain, that one would be satisfied for anything on that local broadcast.
Yes, correct.
Is that correct?
Yes, correct.
All right.
Thanks,
Good.
Michael.
I will admit and I don't want to talk more about it because I would take over the whole class. I will admit that I'm definitely still a little confused as to the role the link local address plays. I do want to, before we go in, I don't even want to go into that. Well, you and I can talk later about that one-on-one.
I added a slide, a deck.
Please do. Please go into depth on that. I'm still a bit, I keep trying to force this into the IPv4. I keep trying to do a one-to-one correlation with how it works with IPv4, and I know it does.
I added a slide to the chat window.
Yeah.
It's called IP version setnet. It's subnetting. It has all of those like quick examples of what you're looking for.
Yes.
And I also added the EUI 64. That's sooner or later, you're gonna have to look at that too. So these are what I send my students just to get them when they can look confused on how all of that stuff work and how it's linked in together. So inside of those slides, you'll see some examples of the configurations and everything, and where you need to use in the different types of IP addresses for IP version 6. So hopefully that'll be helpful for you.
I will say that I'm actually on a tablet, so right now all I see is the screen, but I'll definitely check it out. I will say that the thing that always helps me the most personally, and this is just, this is unique to me. I say unique to me, but many students are like this, I guess. I love the analogy concept. Like analogies work for me.
Okay.
So when we say, hey, the IP address is the envelope, and and we're addressing the envelope, and then we're changing the address, or we're putting that envelope in another envelope, those types of visuals, that skeuomorphic concept works really well for me.
Okay.
And I don't know the real world analogy of link local, and that's probably the problem. I get with the addresses, the IP6 addresses, but I do want to get to a question on link local. Link local is FE8001, right?
Yes.
There's no leading zeros in the IP6. There's not even leading colons in the IP6. So so if I'm looking at IP6, we're missing a crap ton of actual digits there. So when you don't, if everything is a leading zero, do you also get rid of the colons? Is that assumed?
No. So with your link local, it's shortened down. So if you're looking at my screen here, if I go into, let's see, interface, and I do IPv6 address.
I just didn't understand why it was so small compared to all the other IP6 addresses. I really should be why.
Really, to tell you the truth, I haven't really really dug into it. It's always from my
It's the rules.
It's like
it's two sets of rules that have to be applied to the leading zeros.
Yeah.
First, you have consecutive zeros that 3 sets in a row. You can replace them with 2 colons. Now, if you have anything that's leading 0, if it's 0, E5, 6, then you can take that leading 0 off. Now, you can only use that double 0 leading 0 one time. And then the rest of them, if it's a set of 2s, you can use that as a colon, 0 colon. So I'm gonna I got a document that also explained that very well. So as far as why is it condensed? Because really the FE008 is colon/10. So it's a whole lot of zeros that you do not see. It's a series of zeros.
That's what I would love, and that's the thing.
It's the rules.
Yeah, that was not there. Nobody explained it. It wasn't in the Cisco stuff. It didn't.
No, it's not.
And how do you wrap your head around it if they don't tell you?
It just takes some time, man.
It's in chapter 11 and chapter 12, but I still don't get it.
Yeah, it's kind of.
Yeah.
I still confused.
Sorry, you're getting a double blasted shotgun.
Oh, no problem. Hey, it helps me out. It helps me out too.
I'm on a tablet. I don't know who's speaking and said about the double zeros because literally all I see.
This is Michael Allen. I'm about to send you the rules to you right now. Give me one.
A lot of Michaels. Michael Bellin. I'm Michael Peluso. Thank you, Michael Allen. I appreciate it. Thank you.
I'm gonna see this rule. That you apply this rule, that you're gonna see how that works out. So
yeah, what's kind of odd is that it goes into shortening the IPv6 addresses later on, but it introduces it to you with the configurations in earlier chapters. So that's kind of,
well, that is a royal pain in the butt. I got to tell you, from somebody who likes to understand what the heck is going on, and there's a few of us on this call I know who are like this. That has been a little frustrating to me. So
IP version 6 is a little strange. You just have to, it takes some time.
It really took some time. And to be honest, for me, I didn't really dig into IPv6 until I started instructing. I had to dig into it. But before that, like when I was working my previous job, a lot of the engineers and stuff, they hated IPv6. I would hear them say, well, if we implement IPv6, I'm leaving. It's some of them, they just hate it. So it's and the thing is, the addresses is so long, it's easy to mistype. But as far as I know, before we move on real quick, I know I saw Bob had a question about the default gateways. So it's the concept with the default gateways is still the same as IP version 4. So with you here, we got this IPv6 address, and our first usable address would be a 1 here that we could use for a default gateway. And another thing with the default gateways, long as you're using an address in that network, any address would work for a default gateway. So if you're looking at a network per se, let's say, let me bring up something here. So if we got the network of 192.168.10.0/24. So this means that our network is 192.168.10.0, and we have hosts inside of that network. So if you think about it, the network would be the basket, and the host would be the edge. So we have 192.168.10.1. and we can go up to 192.168.10.254.
Can I bother you to change the to just set it to page width?
Sorry.
So if you go to view and hit page width, it should do it just as well. Over here, just like I'm pointing at your screen. Yeah, bingo.
There you go. I couldn't see it either.
Sorry. If it's sorry about that.
I yell at my students all the time and ask them to do that when they're asking me a question.
Yeah, so here, like I said, this 192.168.10.0 is our network or let's say our basket, then we have 192.168.10.1 all the way to 192.168.10.254. That will be our eggs. And then we got this one special egg. That will be the broadcast. So technically, we can pull any addresses in this range. And if we assign it to our router interface and we connect the switch and then we connect the PC to that interface, whatever address we chose from here is going to be our default gateway. So whatever address you have assigned on your router interface that's connecting to that link, like so here, whatever address is here will be the default gateway for this PC here, and also for this PC here. But
okay, I'm going to ask a question. And this it's directly relates to what you're speaking about.
Okay.
When I was working on, I guess it was 11.7.7 or 11.5.7, whatever the today's. One of the things that I had to fill out in the chart was the default gateway, and I went and put in default gateways, and then I honestly I checked online to somebody who goes through the whole thing. I always do the work, and then I double check online, and I'll watch a video of somebody doing the packet tracer.
Yeah.
And they said NA for default gateway. Now, if I've got two routers together, router A to router B, is router A's default gateway the IP address of the interface it's connected to on router B? So A is talking to B. Does a router ever get a default gateway, or is default gateway always not applicable?
So the router's address is ultimately is the default gateway for your links. Now, if you got two routers connected together, then they're just a point-to-point link.
Yeah.
But does that? But okay, so I've got a router. So let's say my company's router, and I've got a router at the ISP. Would I change my routers? Do I apply a default gateway to my router using the IP address of the interface that it's talking to that's connected to at the ISP?
No.
No, so it just never has a default gateway.
Can I help you, Michael?
Yes, yes,
yes, please.
Yes.
There's 3 mics here, so.
So this is how I explain to my kids. So a router is a broadcast blocker. So wherever that link that you're connecting to that router is going to be your default gateway out for everybody who's connected to that router, switches, PCs, or whatever. So whatever interface that you have connected to that router is theoretically the IP gateway out.
Yes.
For any device that's connected to that router in that broadcast domain. So you have to be thinking like, whenever you see a router connected to anything below it, that's a broadcast by itself. That's a separate network, local network.
Right, but what about the router out to the rest of the world?
Now, the router out to the rest of the world, if you're talking 2 routers connected to each other, that's going to be a different connection that only uses 2 connections per. That's a point-to-point connection. So now that router on both ends of those serial points, that's when your routing comes to play, where you can actually exchange information between one side of that broadcast domain to the other side. But until you get that broadcast domain down, then you're going to know where your local network is. And wherever your local network is, that's defining your IP gateway out.
Okay, so I'm going to try and
visualize. You're about to do it right now. So anything under that router, that switch in that PC under router 1, that's a broadcast domain within itself. And the only way out,
I'm going to explain it like I would explain to a student, or like I think. So I've got an address. The address is, let's say it's a Netflix server, and I'm on my local network. And so I write, using the skeuomorphic design, I write the address of the Netflix server with a request for video. I stick it in the envelope. I put it on the address. It goes up and it says Netflix. So it goes to my that address. It goes to the switch. The switch automatically sends it to the router. The router looks on the local network and it says PCA, PCB, PCC, and PCD. None of those PCs on my personal network are Netflix because it's a personal network. It's the network in my house, right? There's no Netflix in my house. It's just my house. So that router needs to send that to the cloud, basically to the ISP it's connected to. That router I don't need to say, hey, this IP address is, hey, Mr. Router, this IP address at the ISP is labeled default gateway. It just automatically knows, well, there's nothing here on my local network that reads Netflix, so I'm just going to send it on to this one other connection I have because that's all I'm allowed to have.
I think you're missing a part in there as far as the DNS server. We'll have to convert that IP address to a readable name. So
Right.
that local, wherever that Netflix is located at, it's going to have an IP address associated with it. Now, if it's not going to be in that IP routing table of the router one, if you're trying to send it out of there, it's going to look up that table. If it's not there, it depends on what type of protocol that we have in place, whether it's OSPF, is ERGRP, however that thing is set up to look up its neighbors to figure out which way to find your particular request.
Yeah.
So
There's a lot of other things going on.
Yeah.
So let me pause you. So default gateway doesn't exist because there's all like nearest neighbor replaces default gateway. It's just going to send it along using a different protocol.
Well,
So this,
go
let me
ahead,
see,
Mike.
like, so technically, if you're looking at this diagram,
Mm-hmm.
your end devices is what's going to need default gateway. The
Mhm.
default gateway is going to be configured on this interface. So
Right.
technically, this interface is your default gateway. So if
For the
this-
PC.
yes,
That
for the
everything.
PC,
for the PC, for the switch, this is where it's default gateway. So pretty much the default gateway is your way out. So if this PC wants to get out of this link, it has to send that packet to its default gateway. Once it gets
But
here,
how does it? I wish you were here. I'm sitting here pointing at my tablet. How do you get from here to? Like,
Well, you got one more thing, Michael. You
Yeah.
got to make sure that your management IP address on your switch is also set up.
yes,
And it has an IP address, and then you have a separate command for the default gateway on the
on the
switch.
switch. Yep.
So that's how it gets out. All right.
So get to the router. My Netflix address is on the router.
Uh-huh.
How does it know to go
So-
from router doesn't see it on the local network? It doesn't see it on PC. It doesn't see it on switch. How does it know to get from router 1 to router 2? How does it know to go make that horizontal line?
Here's where you're going to have a routing protocol in
Yeah.
place. So
Router
you're going to
table.
have ERGRP, OSPF,
Or
and it's
camera.
going to, which depend on different companies use different things.
So routers never have a default gateway.
No.
No,
Okay.
I just tell my students there's a table there that
Yes.
has routes on it. Just
Yeah,
like
that's-
my subdivision, I have a map on how to get out of my subdivision. There's only one way out.
That's
Correct.
I
why
don't care. Once
Okay.
you left my subdivision, I don't care how you get there from
you
there.
gotta show
Correct.
I'm
your IP
responsible to get
routes.
you out of my subdivision.
If you show
Okay.
your IP routes, you know where your routes are, and you also do a show interface brief. That'll
Yeah.
give
Yeah.
you all the details on what's connected to all of your connections.
So
So
let
here-
me
Yeah.
let me
Just
explain
just
real
think
quick.
about the default gateway as the main post office.
Yeah, that's it.
yes.
How
So
about
the
that?
reason why I asked that question is because on the topology in the lab 1175 lab,
Yeah.
it's network to a router to another router to network. And so I automatically assume, remember, I'm a novice at this. I sold the product for 20 years, but as far as, putting it together, a totally different story. And I thought to myself, looking at the topology, well, there's only one exit from this router. So therefore the router should have a default gateway, which is the other router. That's what I was thinking in my brain, because I'm looking at a map that has two routers, and those two routers are each connected to two switches, which are each connected to hosts.
And I think where you're getting your information kind of backwards is that the router doesn't have a IP gate like a default gateway.
Yeah.
You have a routing table. That routing
Right.
table tells you where to route your package. So once it starts at that default line, it gets into routing. It doesn't
And
use the default routing anymore. Your default is
And
already
the-
set. Yeah.
and then this is where, when we do the packet tracers, it actually had a blank for default gateway on the routers. And like when you're filling in those tables, it
Yeah.
should say something in those tables that says handled by routing tables or handled by what have you.
Right.
You don't like, so automatically I'm sitting here and I'm going through this exercise and I'm thinking, okay, there's a blank. I got to fill in that blank with something because that blank is labeled default gateway.
Well, normally those blanks are NA for the routers. You shouldn't even have any option to enter a IP gateway.
No, I'm not on the router. I'm in the
Yeah,
assignment.
even
the
your
assignment.
topology, when you look at your physical topology or your logical one, and it tells you what when you're filling out that chart.
The chart.
Yeah, it should have an NA in the routing part of it. It shouldn't have any
It
option.
did not have an NA, and that was what was screwing me up. It just
Okay.
so it literally was asking me. I mean, if you look at that chart, it's something you're supposed to fill in per the instructions. There was a blank, and the blank said default gateway for the router, and that's where I was getting really confused because I calculated, okay, this router is connected to this other interface on this other router, so that's got to be the default gateway because I'm a novice. And then I go and I check the answers online. It's like, whoa, it says NA. And I was having a really hard time wrapping my head around that because packet tracer, the instructions were asking for an answer for a default gateway for the router. That's where this whole thing came from. And I apologize if I'm asking too many dumb questions here.
No, you good. You good. No.
Hey, Mike, the way to look at that is whenever the information comes into the router, you can't have one default gateway because it depends on what the destination IP address is.
Yes.
So because it's going to look at the packet, it's going to de-encapsulate it and look at the IP address, the destination IP address, and then whatever interface that destination IP address is connected to, that's what it sends it out on.
Yes.
I get
correct.
that, or at least I sort of get that. It's the stuff is coming slowly. I swear I got to work twice as hard and twice as long as what I feel like I should be working. But I want to thank everybody for like throwing this stuff at me because I'll be thinking about it for the next 3 days.
No, I think they're very good questions.
Yeah,
because these are the type of questions you get from your students, and you have to be prepared for them.
Yeah, so it's
Yeah.
I appreciate it. Because even if we don't get time to, we still got Wednesday. I can start going over the subnetting and all this stuff. It's just that I appreciate you asking the questions because most time maybe somebody else got the same question. So
Correct.
I appreciate it. But that
Hey, Mike, and this
Yeah.
is Lorraine, and I can tell you, I am a novice. I'm totally new to this. So I don't know what questions to ask. So the ones you're asking, I'm going, oh, that's what I'm doing. So please keep asking.
Yeah.
All right, I will keep asking questions.
Okay.
I can tell you, I've done this for, since 2000. I took CCNA in 2000, didn't take the test. But I will tell you, it's like there are two types of enterprises here. We were a managed service provider, so we only had one router and it went to the ISP. We didn't have a large enterprise that we were working on from router to router. And if we had external sites, we used a sonic wall and then did a tunnel from sonic wall to sonic wall. So I guess in that sense, but for the most part, everything we did was just a router to the internet, the ISP. So a lot of this is new to me too, and I've been doing it since class A, B, and C subnetting.
Yeah, so
Don't feel confused. There's some of them, and it's difficult because I'm trying to put this into the small enterprises that we did, and it doesn't work.
What it may be, Karen, is so if you was with like a managed service provider, what you're coming into would be what's shown now in this course. So you're coming from the outside in when you may be going through your router or your firewall, creating that VPN. But when you come in on your customer's equipment or the ISP, you're coming in on their inside network, which is kind of the setup of what we're going over now in the
That is
CCNA
correct.
one.
Our focus mainly was the inside network,
Yes,
not router to router to router to get to that network.
yes, yes. So, and that's yeah, usually a lot of the managed service providers, you know, that's usually how they're set up. Okay, so any other questions? Like I said, I appreciate the question and everything. I feel like it was a good learning session for everyone.
Is there a chart somewhere out there on the internet that anybody knows about that shows the IPv6, the prefix hex, and that equals the global unicast, the local link unicast, that gives
Yes,
us a little bit more of a chart?
I think there's a chart in one of the modules coming up. Probably. Here, your types of your IPv6 unicast addresses.
Okay,
Yeah.
that's what I need. That helps a lot.
That
Yeah,
document
so
that I sent you earlier, it should have all that in there.
Yes.
That IP version.
I didn't see that in the chat room.
I sent
Yes,
it to everyone.
Yes, it's in the.
Download it. You'll see all that information.
Yeah, you have to click the download on it in order to see it.
Okay, thank you.
Yeah, that has, matter of fact, some of those things you see here that I brought into my slides for my kids. So you have those and all the links that you was asking about are in that document.
Yes.
I just put a link in the chat. I found a Keys internet guide. It talks about IPv6 explained for beginners. It helps me. So I attached that. I put the link in the chat if anybody wants to look at it.
Okay. Yeah, so it's on in like I said in module 12 also. But with the IPv6, the main thing is just getting that practice with it. The subnetting part for it is kind of easy once you understand the format of the addresses, and just usually just going out and doing labs with it. That's what got me kind of comfortable with it a little bit. So I'm gonna go ahead and start module 11. We may not finish it all. I plan on trying to get to like just the classical subnetting part. So with module 11, you go into the, take a deeper dive into the networks and the network addresses. So it's showing you how you can tell the difference from your network and your host portions. So it's showing us that our IPv4, we have a 32-bit address. By 32 bits, it's meaning that when you break down this 192 into binary, you have 8 bits here. That creates that 192. Your second octet, you break it down, you have 8 bits. Third octet breaks down to 8 bits. Fourth octet, 8 bits, which those bits added up is that 32-bit network portion. And then the way that you get the 192 is you have your placeholder values. So for each octet, you have an imaginary, I call these my placeholder values, and I write these out anytime I'm doing subnetting or anything. So for each octet, you have the first bit, the value of it is 128, second bit 64, 32, 16, 8, 4, 2, and 1. So when we come up with 192, we had a 1 in the first place, which was 128, and a 1 in the 64th place, which when we add it together, we get the 192. So What's shown here is how the subnet mask is used to determine that network and that host portion. So it's going into the subnet mask and showing that to figure out your network, oh, sorry, that wasn't for me. Oh, sorry, Kay, I thought you were asking me a question. So pretty much it goes into the process of ANDing, which is how you figure out your your IP address, and you're giving your subnet mask, and if you want to figure out the network. So here's showing our IP address in binary. Then we have our subnet mask in binary. And the process of ANDing is when you take those binary digits and you AND them together. And it shows where you have a 1 and a 1 equals 1, 0 and 1 equals 0, 1 and 0 equals 0, 0 and 0 equals 0. Yes.
Could I interrupt you for just a second?
Yes.
Sometimes I have to teach this to the 13th grade, if you know what I mean.
Uh-huh.
And the way that I teach this to them is I said, what my mama told me is a right thing done in a right way is right. A wrong thing done in a right way is still wrong. A right thing done in a wrong way, still wrong. A wrong thing done in a wrong way is wrong.
Okay.
I've never had a student they always remember, right thing done in a right thing.
Okay.
The
Yeah.
only way to get a 1.
Okay. So a right thing, we have a right thing here, done in the right thing, and you get a right thing. So, okay, I might have to use that one. So in the process of ANDing, as you see here, when you go through in binary, you have your IP address, then you have your subnet mask in binary. And when you AND them together, like I said, a right thing and a right thing equals a right thing. So once you go through the process of ANDing them together, then you would come out with your network. And as you see here, it gave us a host address 192.168.10.10, and along with the subnet mask 255.255.255.0, which is also a /24. And once we ANDed it together, we got the network of 192.168.10.0. And then we go into further breaking down that network address. So within a network address, you have your network address, your host address, and also your broadcast address. So your network address will be the basket or the edge where the basket, then your host addresses will be your edge per se, and then you have that special address for your broadcast. So you have your network address, it's showing here /24 192.168.10.0/24, and it's giving us our first address in that network. So our first usable address in the network is 192.168.10.1, and our last usable address would be 192.168.10.254. And then we have a broadcast address of 192.168.10.255. So for the breaking down those addresses, you have what's called a Unicast, which is that transmission of sending a packet from the source to the destination, 1-to-1. In the example here, you see the PC that's sending a packet to the printer here. So that's a Unicast transmission that took place. It's going from source to the destination of the printer. Then you have your broadcast, which is one to many. So you see it shows here from the PC, our source, then shows our destination where it goes out to all the devices except for the device that sent it. So that's your broadcast, one to many, Unicast 1-to-1. And then you have your multicast, where it sends it to a specific multicast group. So here it would be one to many, and the broadcast would be one to all. So you see here where the PC is sending the multicast packet, and it's going to just the PC's 116 172.16.4.3 and 172.16.4.4. And it's using the multicast address of 224.10.10.5. Then we get into our types of IP addresses where we have your private, and then you also have your public addresses. So for your private addresses, you have the ranges of 10.0.0.0. This goes into 10.255.255.255. Then also you have the ranges of 172.16.0.0, which goes to 172.31.255.255. And also we have the 192.168.0.0, which goes into the 192.168.255.255. And what's unique about these addresses is these addresses are not routed on the internet. So these would also, you may hear them called your inside addresses. So your inside addresses, meaning that from the inside of your network, inside of your home, this address probably looks familiar. Your 192.168, which is usually common on home networks, and different organizations will use these private addresses. It's because it's not routable over the internet. So I could have a 192.168.10.1 on my PC or 10.5, and someone else could have the same thing on their PC. And being that those addresses are not routed to the outside, we won't have no issues. Then you have your public addresses, which those are the ones that's routed on the outside via your ISP. So then we have what's called NAT. So NAT, this is what's going to translate those private addresses to public addresses. So from the inside of our network here, we have a private address. So when we want to go out to the outside world, let's say Netflix, Facebook, what happens is we send our packet, and our packet goes to our edge router, and our edge router usually has NAT implemented on it. And what it does, it translates that private address that we have inside to a public outside address to route to the internet. So one thing I usually tell my students is, I usually tell them the story about when I was younger. So when I was younger, you know, my first div into computers was trying to download illegal movies at the time. And I tell them about how I got a message from Time Warner. And the message from Time Warner, it had my outside address, and it showed where they had caught me for downloading the movie. And they was able to take that outside address and translate it to my inside address, which went directly to my house. So that just shows how from your inside address, going from the outside, how NAT translates that private to public. And then as you get on into the Cisco, I think it's CCNA 3, you come along with something called PAT, which is gonna translate, use one public address, and then it's gonna take that inside address and it's gonna translate it using that one public, but the difference would be instead of a one-to-one translation, it's gonna have that same address, but it's gonna keep, because it's gonna keep up with the conversation via the port numbers. The port numbers will be different. And Karen, you're correct. It's the exact reason that hackers use the virtual addresses so that they can't be found also.
The dark net is full of places where you can go and find these addresses where they can't trace it back to you.
Yes.
And that's why they're doing that.
And then we have your special use addresses of your loopback, which is also referred to as, I call it your home address, call home. Loopback address is usually good to tell if your PC is having issues, if you're having some kind of connection issues. Usually the first thing to test would say, hey, see if you can ping your loopback. Then we may say, okay, you can ping your loopback, you get a reply. It lets us know that TCP IP is operational on that host. And then you have another special address, which is the linked local addresses for IPv4, and it's also known as a PIPA address. So this is used by your Windows PC to self-configure when there's no DHCP server available. Now,
Is question, is
Yeah.
the loopback address, is that its only purpose? Is it exists simply so we could check our existing our existing host to make sure that everything's configured properly?
yeah, so it's used to check that TCP IP stack on your PC with your NIC. Other than that, you will configure a loopback interface on your routers to implement the ISP, but you won't use this address here. You won't use that address. So the only thing I know of it to be used for is for testing your TCP IP stack.
I used it for, if I had a standalone DNS server, I would
Uh-huh.
tell the DNS server, you are it, 127.0.0.1. Don't go out and look any further.
Okay.
Find it in yourself. So I
Okay.
tell it, your DNS server is you, 127.0.0.1.
Oh, okay.
So the DNS server for itself, it
Uh-huh.
only sees, the only thing it sees is itself. For everybody else, the whole point of the loopback is I'm on this host. Let me make sure that this is working because I can't see the rest of the world for some reason. So let me make sure my TCP IP stack is working. So let me ping my loopback. Okay, I'm getting the ping. So we know that the TCP IP stack is working. Therefore, the issue that whatever I'm trying to troubleshoot, it's somewhere else. It's not on this PC.
It's on up the layer.
Back in the day, back in 2000, you know, when you had drivers you had to download back in 1998,
Yes,
that
ma'am.
you'd also ping yourself to say, okay, it's either the driver or the NIC card.
Yes,
NIC
correct.
card used to yell out. They would go crazy and start yelling all the time. So
Yep.
we used it a lot back then, but they seem to have figured out these issues on NIC cards.
Yes, we used it a lot when I was at the hospital for troubleshooting. Like if I went to a PC and everything looks correct, you know, I start pinging. Okay, let me ping my loopback. Okay, I can ping my loopback. I would kind of go up the go through the topology. So I would say, okay, next step, let me see if I can ping my gateway. So I would go through and use that. So it's very good for troubleshooting. And then about the PIPA address, usually that a PIPA address, unless you don't have a DHCP server, but it's gonna assign it that address. And also for me, I look at a PC and I see this address, I know that we have issues. I know that, okay, so something going on with my PC ain't getting an address from the DHCP server we have on our network.
What I tell my students is if you do an IP config and you see a 169.254, call the babysitter, you're not going home tonight.
Yep.
You got something's wrong with some type of connectivity. You got to figure out who all has it.
Yes.
What's going on with DHCP? It's a long night. You don't want to see this.
Yes, we had an issue where some of our Cisco stat switches that we had the DHCP servers configured on the actual switch stats, the 3750s, and for some reason it would just get hung up and it wouldn't assign addresses. So PCs would every day more PCs getting this address, and we usually end up having to reboot the whole stack or something of that sort. But it usually turns out to be a longer night. Then we go into the legacy class for addressing. So this is where you get your class A through E. Class A shows our address range. Your class B, which is /16, /C, class C, which will be a /24, and you see your address range here. And also you have your class D and class E. So it also shows us where with this class for addressing, a lot of addresses was wasted, many of our IPv4 addresses. And also that it was replaced with class list addressing, which are gonna ignore those rules of the A, B, and C. So what happened was with the class for addressing, pretty much you had a lot of wasted IP addresses, which is, I know ever since I was in Kelly's class, you know, he was saying that there's a shortage on IPv4 addresses. So that's where we come up with the class list addressing, and you start doing your variable length subnet and to save some of those addresses. And here it goes through the assignment of the addresses, or how the internet assign numbers of authority managers, allocates blocks of your IPv4 and IPv6 addresses to 5 regional internet registries. And they're responsible for those allocating those IP addresses to ISPs, who provide those IPv address blocks to smaller ISPs and different organizations. Then we're looking at network segmentation. So we have what's called your broadcast domains and segmentation. So here is showing, like Michael was saying earlier, you have your routers separate broadcast domains. So it's showing here where we have 4 switches and there's 1 broadcast domain. And a lot of broadcasts, so you have some different protocols that use broadcast. And then multicast, you have ARP, you have DHCP. When a host is put on this, if a host connected to this switch, it boots up, it tries to reach out to get a address from a DHCP server. So that sends out a broadcast. So your broadcast, when that PC sends that broadcast for that address, is going to send out that broadcast out of all ports on the switch, except for the port that the PC was connected to. So the broadcast will go out of all ports on this switch. Once it comes here, the broadcast will go out of all ports here, all ports here, all ports here. And then, like I said, when you get to that router does not propagate broadcast, so the broadcast will stop here. But what this did was it makes your networks slow. You know, your networks are not efficient, because let's say we had 10 switches here. So it's every time a PC boots up and it sends out that broadcast, it's going to bog down your network. So then came along the solution is to reduce the size of the network to create smaller broadcast domains. And this is where our subnetting comes in. So it's showing here where we went from 1 broadcast domain with 400 users. Then with subnetting, what we did was we created 2 separate networks, and now we split those users. So we got 200 users on this network, 200 users on the next network. Therefore, when those users send out, when those PCs send out broadcasts, it's not bogging down the network like it would if 400 users in 1 broadcast domain was sending out broadcasts on their PC. Then some of the reasons for the segmenting the networks, like I said, is going to make the network more efficient. It's going to reduce overall traffic, improve the network performance. You're able to implement security policies between the subnets. And also it's going to reduce the number of devices affected by abnormal broadcast traffic. And then you have where subnetting, where you can go in, some organizations may subnet per location, as it's showing here. You have your location, and for each floor, you have a different network where it's subnetted. Then you have some that may subnet it by group, where you have admin, human resources, accounting, students. So by doing this subnetting, they can apply security policies that might say, okay, I don't want my accounting department PCs to be able to reach the admin PCs for some reason. So yeah, you're able to kind of get more granular with your security policies that you may have. And then you have where you can do it by device type, where you may have a server farm and you have a network for all the servers. Then you may have a printer network for all your printers. Then you have a network for all your regular hosts, your PCs, your laptops, anything of that nature, anything connected in. Then looking at subnetting on an octet boundary. So you have where it's showing where your networks are most easily subnetted using at the octet boundary of /8, 16, and 24. So that /8 is also known as the CIDR notation. So instead of me saying that this network is let's say if I had a network of 10.0.0.0 and I'm using /8. So instead of me writing out this network is 10.0.0.0, the subnet mask of 255.0.0.0, I could just use the /8 to indicate this subnet mask. And also it's showing that subnet mask in binary, where you have your networks here, and then you have your host bits. and it's showing the number of hosts that can be created from this /8. Then also from a /16, it's showing from a /16, we can have 65,534 hosts. Then also from a /24, we can have 254 hosts. Then also it goes in to show the tables subnetted from a /8 to a /16, and then also using the /24 mask here. Then showing the table that shows the 6 ways to subnet a /24 network. So when you're looking at a /24 network, you got your first 3 octets that's used for your network. So you only have 8 host bits that you can borrow from. And then the most that you can borrow is up to a /30, because once you borrow any more, it's not going to work, because you're going to need a network and a broadcast, and that's not going to create enough hosts to make that work. So it shows from /25 how we can create 2 subnets, 126 hosts. From a /26, we can create 4 subnets, 62 hosts. /27, 8 subnets, 30 hosts. /28, 16 subnets, 14 hosts. Then /29, 32 subnets, 6 hosts, and /30, and so on. Yes.
Can I interrupt you one more time and
Yes,
give
no
you a
problem.
real life example of this chart right here?
Yes.
And then I'll shut up. I've
Oh,
said
no
too
problem.
much.
No problem. You're good.
Okay, so routinely we used AT&T in the managed service provider group that I was in.
Mhm.
And routinely we would tell AT&T we need 6 public addresses, one for our web server, one for the Exchange server, one for the VPN, different things. We need 6. They'd say, oh, sure, ma'am, here you go. But they would give us the wrong subnet mask.
Yes.
And I would have to call them up and I'd say, either the IPs are wrong or your subnet mask. Oh, no, ma'am. We have the experts here. Have a nice day. And I would have to break down exactly what you're showing here
Yes.
to them and say, look at your ones right. They had no clue about subnetting. They pulled it off of things.
Yeah,
and I would show them, look, a ones here, you've got 3 ones set up for your network address. That's not going to work. And then I had to show them the binary continuously. And generally it was one of my husband's friends at AT&T, and I had to give them the lecture on subnet masking. So I'll shut up.
Oh, no, that's great. And what's weird is, I know you said that none of them knew how to subnet. A lot of times I know out in the, in the field and on the job, a lot of times, like, I know for me, sometimes we would use subnet calculators, but for us, it was, let's say we had hospital departments, then we had, let's say, the clinics, but we had them all in a chart that showed our IP addresses and our network. So what would happen is we may have created one office and put them on this network. Then a new one came up, we put them on the next network. But then usually what happened when we had to go in and subnet was that first office that we created, they added more devices than we thought they was going to use. So now they're running out of IPs. So now we got to try to carve out a subnet between those two and to give them more IPs, or either we will start them on another new subnet or something to get to create it. But it's I know for me, my interview, when I went to networking, I think I was the only one that got the subnet part right. Just for some reason, it stuck with me. All right, Mike. See you later. So here it goes into the subnet of /16 and a /8. So it goes down into how you can your number of subnets that you can create, and also your number of hosts. And another thing too, like a quick way to tell how many subnets and how many hosts you can have is by using your powers of 2. So if you do 2 to, as we see here, they borrow 1 bit. So 2 to the first power, that's 2. So when you're pertaining to the ones, that's going to be your number of networks. So 2 to the 1 is 2. So we can create 2 networks. But then if you want to know how many hosts you can create on a network, you do 2 to the power how many zeros or host bits you have. So if we did 2 to the 8, 2 to the 15, this would be our number here, where it would actually be 32,768. You have to take away 2 for the network and 1 for the broadcast. So that's a quick way to tell how many hosts you can create, and which it comes into, it comes in handy also when you get into your subnetting. Yes, correct, Tom. Calculating your networks is left to right. Calculating your hosts is right to left. So here's showing where they're creating 100 subnets using the /16. So using that /16, 100 subnets, you see here they go and show how many bits they had to borrow. So for 100 subnets, remember now we're calculating from right to left. You see 7 bits, that's gonna give us 128 subnets. So we can fit 100 subnets here. And another thing too, when you're doing your subnets and your hosts, the amount of hosts or amount of subnets you need is not going to come equivalent to these numbers. It usually, let's say if we needed 65 subnets, then I would have to use this 2 to the 7th power, because 2 to the 6 is only going to give me 64. And the same thing when you're doing hosts also. If we needed 65 hosts, I would have to still go up here to use 2 to the 7th power in order to get the amount of hosts that I need. And here's showing calculating for 1,000 subnets. And as you see here, where they end up borrowing 10 bits, and they went from a /8, and now they went to a 16/18 here. So that kind of stops us at the variable classful subnetting. I know it's a little bit after 5, so I guess Thursday, what we'll do is start doing some exercises for the classful subnetting, just to make sure everyone's good with that. And then when we come back Monday, I know Kelly, he wanted to stay on this chapter for a little bit also. So most likely he'll run back over it again too, just to make sure that it's, well, we'll start variable length subnetting also, just to make sure that everyone is comfortable with subnetting. Usually I tell my students that, you know, subnetting is I think it's important to know how to do it without the calculator, just because, especially for job interviews. Every job interview I did, every job interview I was a part of interviewing someone else, we would always bring up a subnetting question just to see if they could do it. Subnetting and also a topology for them to configure. So I always try to encourage my students to try to learn it. And, you know, everyone does it a little bit different. Kelly, like I said, we'll go over the 7 holy steps. I like that diagram. Before I knew about that diagram, usually for me, I usually like to know, and I usually do this all the time. When I took the CCNA exam, first thing I wrote down is this here. I wrote down my placeholder values, and I wrote down my powers of 10, because I knew that if I had to do some kind of subnet, as long as I got this, I'm okay. But other than that, was there any questions or anything before we end?
Hey, Mike,
Yes.
for those who want it, some additional subnetting videos is
Yeah.
available with Professor Messer.
Okay.
He has some good subnetting videos as to how can you organize your information if you're going into the certification building to
Yeah.
attempt your certification. He has some good ideas that
Yeah.
I just wanted to throw that out.
Oh, yes, yes. It's you know, it's a lot of times, yeah, it's best to have a plan, especially when you're going to take the cert of. I know for me, back when I took it, it wasn't this current one. It was the one where you had to learn PAP and CHAP and all those technologies. So that's where you know, I had to kind of in my head have what all I wanted to write down doing that. I think they give you like 5-10 minutes to write down whatever you need to write down. So I was doing that. I was able to come out okay with it.
Yep.
For Bob, he was saying Professor Messer. Do you know that address, Tom, or is it just on YouTube?
It's just professormesser.com.
Okay, professormesser.com.
Yes, all one word, professormesser.com. And
Okay,
it'll
cool.
be in he has videos from A+ to Network Plus to cybersecurity.
Okay.
As far as networking, he talks about IPv4 and IPv6, and he goes into subnetting. So that's just a website that I use a little bit.
Do you
Yes.
have the link? Do you have the link to that? You can post in the chat window, please.
Yes.
Okay, thank you.
It's just like it is. It's just professormesser.com. And then his IP addressing videos will be under the Network Plus. But
Okay.
he has some free videos that he shares with the world.
Cool. Okay, I'm gonna stop the recording real quick here.